Hello, guys. I would like us to look at complex numbers. Now, a complex number is a number that has some real part and some imaginary part. The real part being the part that does not have J, and the imaginary part being the part with J. And this is the imaginary part. Now, let's say, for example, you're given a quadratic equation like x squared plus 1 is equal to 0, and you're told to solve. This will give x squared is equal to minus 1. Evaluating this will give x is equal to the square root of minus 1. Now, we are not able to evaluate the square root of minus 1, so we will assume it to be j. So we take the square root of minus 1 to be equal to some j, such that now if we are evaluating this, the answer of x will be equal to plus or minus j. And this is exactly how the complex numbers come about. So for example, let's say you're given a quadratic equation, x squared plus 2x plus 5. So let's say you have x squared plus 2x plus 5 is equal to 0, and you're being told to evaluate this. So using the quadratic formula, so this is ax squared plus bx plus c is equal to 0. To get x, we use minus b plus minus the square root of b squared minus 4ac, all this divided by 2a. So what's going to be the value of our x? Our x will be equal to minus 2 plus minus the square root of 2 squared minus 4 times 1 times 5. All this divided by 2 times 1. 2 times 1. And what does this give? Evaluating this, we have x is equal to minus 2 plus minus the square root of, so 4 minus 20, and that will give minus 16. All this divided by 2. So this will give x is equal to minus 2 plus minus. Now I can be able to write this, since we already know the square root of minus 1 is j, I can be able to write this as minus 1 times 16. All this divided by 2, so that I have x is equal to minus 2 plus minus the square root of minus 1, the square root of 16. All this divided by 2. Hence, x is equal to minus 2 plus minus the square root of minus 1 is what? J. And the square root of 16 is 4. All this divided by 2. So this simplifies to minus 1 plus minus j2 or 2j. So basically, when we're evaluating the square root of a negative number, we will end up having a complex number. So this is our real part, and this is our imaginary part, the part that contains the j. Now, how exactly do we go about getting the powers of j? Now, since we've already established that j is equal to minus 1 powers of j, if we were to get j squared, then this is obviously j times j. So this is equal to the root of minus 1 multiplied with the root of minus 1. And this is obviously give us minus 1. Then j cubed, this is obviously j squared multiplied with j. Now j squared, we already have it as minus 1. So that is like minus 1 times j. And this gives us minus j. J raised to power 4, this is the same as j squared multiplied with another j squared. And from this, j squared is minus 1 times another minus 1. This will give us 1. J raised to power 5, this is the same as j raised to power 4 multiplied by j raised to power 1. But what is j raised to power 4? We have it as 1. So 1 times j, and this is the same as j. J raised to power 6, j raised to power 6 is similarly just j raised to power 5 multiplied by j raised to power 1. We can write it in so many ways. You can also express it as j raised to power 4, j raised to power 2. So if we evaluate this, j raised to power 4 is what? 1. And j raised to power 2 is what? Minus 1. So this basically gives us minus 1. Or if we would have done it this other way, j raised to power 5 is j, and j multiplied with j will give you j squared, and j squared is obviously minus 1. J raised to power 7, we can write this as j raised to power 6 multiplied by j raised to power 1. J raised to power 6 is minus 1. So minus 1 multiplied with that j, that will give us minus j. J raised to power 8, that is the same as j raised to power 7 multiplied by j raised to power 1. What is j raised to power 7? Minus j. So we have minus j multiplied by another j. And j will give us j squared, which is minus 1 multiplied by minus. This will give us positive. J raised to power 9, I can have this as j raised to power 8 multiplied by j raised to power 1. J raised to power 8 is 1. So 1 times j will give j, and so on. So that is basically how we evaluate powers of j. Now, operation, basic operation on complex numbers. So let's look at addition and subtraction. Addition and subtraction of complex numbers. So if you're given two complex numbers, the real part is added onto the real part and the imaginary part onto the imaginary part. So let's say we have a is equal to 2 plus 3j and b is equal to 4 plus 2j. What is a plus b? So a plus b basically entails you adding the real parts of a to the real part of b. That is 2 plus 4 plus the imaginary part of a to the imaginary part of b. So that is 3j plus 2j, and that gives 6 plus 5j. When it comes to subtraction, the same applies. So it's the real part minus the real part, the imaginary part minus the imaginary part. So we will take 2 minus 4 plus the imaginary part to the imaginary part. We have 3j minus 2j. And what does that give? 2 minus 4 will give us minus 2 plus 3 minus 2 will give us j, or 1j. That's how we go about addition. Real to real, imaginary to imaginary. Okay, what about multiplication by a scalar? So if you're given a complex number and you're required to multiply by a scalar, whereby a scalar is basically an arbitrary complex number. Sorry, a scalar is basically an arbitrary constant. So let's say you're told multiplication by a scalar. You're just multiplying by any constant. So how do you go about that? So let's say we have a is equal to 3 plus 5j. Then what is 2a? So 2a is 2 multiplied with 3 plus 5j. So you will multiply each term to the scalar, the real part and the imaginary part. So 2 times 3 will give 6 plus 5 times 2 will give 10j. That's how we go about multiplication by a scalar. What if you're given two complex numbers and you're told to multiply them? So multiplication of complex numbers. Now, let's say you have your a equal to 2 plus 4j and your b equal to 1 plus 3j. Now, to multiply, we just write 2 plus 4j multiplied with 1 plus 3j. Then we use the normal expansion for this. So you take 2, you multiply with this bracket, 1 plus 3j. And then you take plus 4j, you use it to multiply this other bracket, 1 plus 3j. So what will that give? 2 times 1, that is 2, plus 2 times 3, that is 6j, plus this times this, that will be 4j, and then 4j times 3j, that will be plus 12j squared. But we already know what j squared is. From the previous workout, we said that j squared is -1. So with this, we'll just simplify to 2 plus 6j plus 4j will give us 10j, and then minus 12 because j squared is -1. So 2 minus 12, that is minus 10 plus 10j. So that's basically how we carry out multiplication of complex numbers. Now, what if you're told to divide? You're told to divide two complex numbers. So division of complex numbers. Division of complex numbers. Now, let's say if you're given two complex numbers and you're told to divide, you need to know how to get the complex conjugates. Complex conjugate. So given a particular complex number, let's say A is equal to 2 plus 3j, the complex conjugate is gotten by negating the imaginary part, negating the imaginary part, or multiplying the imaginary part by a negative, negating the imaginary part. Okay, so the complex conjugate of this, so the conjugate of that will be equal to 2 minus 3j. Similarly, if we have B is equal to, let's say, minus 2 minus 4j, the conjugate of this will be equal to minus 2. Negating this one, will have minus, so that will be plus 4j. Okay, so that's basically how we go about getting the complex conjugate. Now, when you're given a complex number and you're told to divide, let's say you're told 2 plus 3j divide by 1 plus j. In order for you to carry out division, you need to multiply both the numerator and the denominator by the complex conjugate of the denominator. So the complex conjugate of the denominator here is 1 minus j. You multiply it both on the numerator and the denominator. That's how you carry out division of complex numbers. Multiply the complex conjugate of the denominator both up and down. By up and down, basically, I mean you multiply it onto the numerator and the denominator as well. So we already did a multiplication. So we'll just go ahead and open this bracket, and that will be it for division. So on the upper side, you take 2, you use it to open this bracket. We'll have 2 minus j. You take plus 3j, you use it to open the bracket. We'll have plus 3j minus 3j multiplied with j will give us 3j squared, but j squared is minus 1, so this will be plus 3. All this divided by, we multiply this to 1 times 1, 1 multiplied with, that will be minus j, this and this will be plus j, and then j multiplied with minus j will be minus j squared, and j squared is minus 1, so minus this will give us plus 1. So the upper part simplifies to 2 plus 3 will give us 5, minus j plus 3j will give us plus 2j. All this divided by the lower part, this and this will give 0, so 1 plus 1 will give 2. So the final answer is 5 over 2 plus 2 over 2j, and that's it. So to carry out division, you just get the complex conjugate of the denominator and multiply it both on the numerator and the denominator. That's it, guys.